Doc, the physics of sound and music, lab 7, and reviewing for our second lab exam. What is a Lissajous figure? How do you obtain a frequency ratio from such a figure? We're going to head over here to lab 7, assignment 7, and here I'm going to get my perfect ratios by tweaking this slightly. I have 200 here and 301 there. This is my vertical motion, this is my horizontal motion, and there we have it. On the oscilloscope, when you make a Lissajous figure, you're not using the oscilloscope in the regular way. Here, the oscilloscope has a special mode where you are driving the horizontal with a wave and a vertical, and the combination makes this nice picture when you have a nice frequency ratio. Here we hit the ceiling 3 times, here we hit the wall, right wall, twice, so the frequency ratio is 3 to 2. How do you obtain a frequency ratio from the figure? We just did that, and know that it says next phase can affect the relationship. So here, the phase, let's look at phase a little more carefully. Memorize that when you have one cycle for a wave, that the phase is 360 degrees. That's what you got. So here, the phase is set to 0 when you come to this page. This is your reference to start with. And then if you shift one half a wave all the way over to here or to there, it's a 180. So here I'm going to go 180. And then I shift it a full valley, or I could shift a full mountain, and that's 180. If I go halfway on that mountain, then that's 90. When I have 90, then I went up halfway. Or if I go halfway to the valley, see here's my 0. And then if I go to the valley being at the center there, that's 90. You may want to play with that a little bit to get a good feel for that. Notice that the phase changes what's going on over here, and you could fold over 2 of the lobes. So when you see something like this, with a little experience, you can see that that's a folded case, and this will unfold to 2. The point unfolds to 1, and it's really a 3. It's really a 3 to 2 up there, 3 to 2. How does phase affect the simple Lissajous figure that has a 1-to-1 ratio? Well, in that case, we will go to lab 7.5. And here we have a 1-to-1 case. We have 1,000 hertz in each case. I have a phase here, 130. If I make that 0 again by just clicking on that button, this is the standard position where we're calling this 0, where you start out making a mountain. So here, once again, if you shift the phase by 180, you've moved half a wavelength in one direction in either case. And notice that that turns this figure so that you have a line unfolds into a circle, have ellipse in most cases, and then a line again. In every case here, it's a 1-to-1 ratio. You hit the ceiling once and the right wall once. It's 1-to-1. Whether you have the point, you're hitting the corner there. 1-to-1, ceiling and right wall. And here, ceiling and right wall. And here, ceiling and right wall. So 1-to-1. Remember, just think of ceiling and the right wall, and you don't double count that way. So I hit the ceiling once, hit the right wall once, 1-to-1 ratio. Knowing the frequency of one of the waves, how can you tell the other? Well, that would be by your frequency ratio. So here, if you have 3 times going up and down, 2 times left and right, that means if you give me one of them, say you give me the left and right one is 200. Then I know this one up and down is 3 to 2 ratio. In fact, common sense, I can see this one's going to go faster because I'm hitting the ceiling 3 times while you're doing it only twice. So that means I would put the 3 over the 2. So 2 into 200 would be 100, and 3 times 100 is 300. Then the answer would be 300 hertz. And if you give it to me backwards, say if this is 300, what's the slower one? Then I would use common sense, 2/3. I know there's 3 here and 2. I know the numbers I'm playing with are 3 and a 2. So I would then use common sense, the 2/3, to bring it down. What are the names of the 8 intervals in the perfect major scale? Well, for that, what I would suggest to do is to head over to your text, the frequency ratios, F, and here are your songs. Now, the lab will do all these songs one by one and analyze them, but here's a quick reference of all the songs. And your ratios are down here. These are your ratios, 1 to 198, which is you had these analyzed in the lab, but this is a quick reference here in this review. Then you can use those ratios to figure out some frequencies. That's what we're going to be asked to do next. What are the frequency ratios? Okay, we got the songs, we got the frequency ratios, and how to calculate the frequencies for notes given do. All right, that's the next thing. So if do is given to be 240, and you want to go up, say, to the major third, you would memorize that the third is 5 to 4. And then since you're going up, you would put the 5 in the attic and the 4 in the basement, so you get a bigger number when you multiply it out. And 4 into 24 goes 6 times. 5 times 6 is 30, and there's a 0. There's a 0 hanging around, 300. You do one, you kind of do them all. How do you calculate the frequencies when you go down? Well, if you go down by a perfect fifth, say, you would know a fifth is 3 to 2. If you want to go down in pitch, then again, common sense, use 2/3 instead of 3/2. So you can use these either way. Like if you go up an octave, you double. If you go down, you take 1/2. You undo it. So use common sense on that, and then use the same logic. How do you apply this when you're dealing with periods or wavelengths? Well, now you got to be careful. Whenever the frequency goes up, the wavelength goes down because the velocity for the medium is constant. So that means you got to reverse the logic. Now think of this: when the pitch goes up, the size goes down. You have a little person on a cartoon, say, talking a real high voice, and then if the frequency goes low, real deep voice, then the size goes very, very large. So that means when you want to go down or up in frequency, just think that you reverse it for the wavelength. So if I say go up a fifth in pitch, I would then normally use 3/2 because I want to go up in pitch. But for wavelength, I just flip it. I use 2/3. And also for the period, you do the same thing with whatever the wavelength is doing. Wavelength and period go together. They're opposite the frequency. So just remember that. Set it up by using common sense. You know, for example, a fifth deals with 3 and 2. So it's going to be either 3/2 or 2/3, depending on what you're doing. If you go up in pitch, it's 3/2. If you on the frequency, if you go up in pitch, that's 2/3 on the wavelength, 2/3 on the period. If you go down in pitch, it's 2/3 on the frequency, but then you have to flip it 3/2 for the wavelength and the period. Just take your time and figure it out for the pitch, and then just flip it if you're doing the wavelength or the period.